Fourth unit, second part, constant enthalpy lines. The enthalpy lines are inclined straight lines and uniformly spaced as shown in the figure. These lines are parallel to the wet bulb temperature lines and are drawn up to the saturation curve. Some of these lines coincide with the wet bulb temperature lines also. Classification of air conditioning systems. Individual room air conditioning systems or simply individual systems. Evaporative cooling air conditioning systems. Desiccant based air conditioning systems or simply desiccant systems. Thermal storage air conditioning or thermal storage systems. Clean room air conditioning system. Space conditioning or space systems. Unitary packaged air conditioning system or simply packaged systems. Central hydronic air conditioning systems or central systems. Central air conditioning systems. So that like that we have different types of air conditioning systems. Coming to individual air conditioning systems, an individual room air conditioning system or simply an individual system uses a self-contained factory-made packaged air conditioning to serve an individual room. Individual means the units are separate. Independently, you have chillers, air conditioning units, quality checkers, filters altogether are supplied separately to individual or independent rooms, and that is what here it is discussed in individual air conditioning system. It is ready to use after electric cable and necessary water drainage are connected. Individual systems always use DX coil to cool the air directly. Air is cooled directly by using DX coil. And individual systems can be subdivided into the following air conditioning systems: room air conditioning or packaged terminal air conditioning systems. So like that we have different types of air conditioning systems. Now coming to the psychrometric processes. Air conditioning processes are most commonly used to achieve a more comfortable interior environment. This is done by controlling the temperature and humidity of the interior space and ensuring adequate amount of fresh air in the space. Temperature control, sensible heating or sensible cooling. Humidity control, adiabatic saturation, steam injection, air washers, cooling and dehumidifying coils. Fresh air, adiabatic mixing of air streams will give fresh air. So there are three methods three important things in air conditioning: temperature controlling, humidity controlling, and quality of the air. These three together comprises air conditioning. So temperature of a system of the air is controlled with the help of either heating. If the temperature is less in cold countries, if the temperature is less, it must be increased. So we require sensible heating without changing the phase of the fluid that is present in it. And sensible cooling is required in the areas of hot temperature desert areas, and in hot countries sensible cooling is required. So by maintaining temperature we cannot condition our air. It is also required to maintain the humidity and quality of the air. How the humidity is controlled? Humidity control can be done with the help of adiabatic saturation. Adiabatic saturation is like an artificial method. Artificially, we are increasing the humidity content in the air. For example, uh, we have to take a chamber and fill it with the water, and from one end of the chamber, air must be forcibly passed through the top layers of the water, and through other end the air will come out with increase in humidity. The top layers of the air, because of the superheated temperature of the air, will absorb the moisture content from the water and escapes into the room, and that is adiabatic saturation process. Like that we have different methods. Steam injection is also increase in humidity. Air washer to increase the humidity. Cooling and dehumidifying coils. Dehumidify, Dehumidifying coils are used to decrease the humidity of the air, atmospheric air. If the humidity percentage is increasing, it is greater than 52, which is considered as the human comfort humidity value, then definitely it requires dehumidifiers, and it is possible with dehumidifying coils. And last one is fresh air. To maintain the quality of the air inside a room, adiabatic mixing of air streams, maybe 20%, 20 to 30% of the fresh air is supplied from outside. After Before we send the air for processing, before we send the air to the chillers, we need to remove 20% out, and we should add 20% in for the maintenance of quality, like oxygen levels inside the air. So so like that we have different processes to maintain air conditioning. Diagrammatically it is shown psychrometric processes. The red we have heating and humidifying towards the red line. Heating and humidifying. Humidifying is vertically upward direction, dehumidifying is vertically downward direction. Towards left direction it is cooling, and left bottom it is cooling and dehumidifying. It all goes according to the temperatures and humidity that is available. Now towards right bottom it is heating and dehumidifying. And in the second quadrant, if we take a curve increasing, a line increasing in upward direction, that will increase the humidity, means humidifying, cooling and humidifying, just vice versa. So here in this sensible heating of air, it is shown that dBT, dry bulb temperature increases, moisture content remains constant. The specific humidity keeps on constant. In heating, when the dry bulb temperature is increased, the moisture content remains constant. Note that relative humidity of air decreases, which may cause dry skin, respiratory difficulties, and an increase in static electricity. Specific humidity remains constant. Next, sensible cooling of air. Dry bulb temperature decreases. Moisture content remains constant. Note that relative humidity of air increases. Cooling can be achieved by passing the air over some coils through which a refrigerant or chilled water flows. A refrigerant or chilled water flows. Adiabatic mixing of air streams for quality maintenance. Many air conditioning applications require the mixing of two air streams. Example, air conditioning in hospitals, large buildings, etc. require that the conditioned air be mixed with a certain fraction of fresh outside air. That's what we discussed. A 20% of the fresh air is mixed and it is again sent into the chamber where air must be conditioned. That is what we call adiabatic mixing of air. So in the graph, that line 1 to 2 indicates adiabatic mixing of air streams, and here that line, dark line towards arrow indicates towards left, constant specific humidity, but the sensible dry bulb temperature is decreasing. And here the arrow towards right side indicates increase in dry bulb temperature. And in all the cases, the sensible heat is remained constant. Either it is heating or cooling. In these two cases, the specific humidity is remained constant, whereas the relative humidity was changing. In one case it is decreasing, in other case it is increasing. And in adiabatic mixing, the specific humidity is changing and the relative humidity almost seems to be same. There is no much change here in the third case. So in adiabatic mixing of streams, we need to check about the humidity, specific humidity, temperature, and the oxygen levels. To maintain the oxygen levels in a proper way, we do require fresh air to be supplied for chambers. And